Welcome, everyone. Grab a seat. Let's just jump right into today's explainer because I am incredibly excited about this one. As a space scientist, I spend practically my entire life looking up and out, way out. And right now, as we're all sitting here comfortably in this class, there is actual human-made hardware hurtling through the pitch-black void of space at tens of thousands of kilometers per hour. So today, our syllabus is taking us way beyond our familiar solar system. We're looking at the absolute furthest objects humanity has ever launched into the cosmos. Buckle up because we are heading out into the deep silence. Okay, I want you to imagine trying to troubleshoot a computer issue, right? But the catch is, the server you're trying to fix is 24.5 billion kilometers away. Recently, against literally all logical odds, Voyager 1 suffered a catastrophic malfunction in its flight data subsystem. Basically, a single corrupted memory chip caused the probe to start beaming back absolute gibberish. The entire mission was on the line. But through what I can only describe as an absolute engineering miracle, NASA teams managed to remotely rewrite and painstakingly relocate 1970s-era assembly code across different surviving parts of the computer's memory just to bypass that one dead chip. And get this, it worked. It actually started sending usable data back to Earth again. It's just a spectacular reminder of the massive stakes of deep space survival, and honestly, a huge testament to how resilient that early technology really is.
Okay, let's dive into this syllabus. First up, we'll meet the Voyager twins. 2, we'll try grasping interstellar distances. 3, surviving deep space challenges. And finally, number 4, our lasting cultural artifact.
All right, Section 1, meet the Voyager twins. Now, what's really interesting about this slide is the incredibly different paths these two interstellar ambassadors actually took to get out of our cosmic neighborhood. Voyager 1, which we'll call the leader, took a very fast, direct route. When it reached Saturn, scientists purposely used the gas giant's immense gravity to basically fling the probe upwards, completely out of the flat, ecliptic plane of our solar system. Because of that high-speed upward trajectory, it officially entered interstellar space, the actual space between the stars, way back in 2012. But then you have its twin, Voyager 2. It stayed much closer to that ecliptic plane, taking what you might call the scenic route. Because of this longer, flatter path, it didn't actually cross that interstellar boundary until 2018. So you might be wondering why the delay for Voyager 2. Well, because it was busy executing literally one of the greatest planetary road trips in human history. Step 1 brought it to Jupiter, Step 2 took it past Saturn, Step 3 was Uranus, and Step 4 took it all the way out to Neptune. Now, this wasn't random. It relied on some seriously specific orbital mechanics, an exact geometric alignment of those outer planets that only happens once every 175 years. NASA engineers spotted this rare window and essentially used the gravity of each planet to slingshot the probe to the next one. It was grabbing invaluable, up-close science data at every single stop, before finally heading out into the deep silence. Moving right along to Section 2, grasping interstellar distances. Let's look exactly where Voyager 1 is right now. It currently sits at a mind-bending 164 astronomical units, or AU. To put that into perspective, that is roughly 24.5 billion kilometers away, making it the absolute furthest man-made object in existence. To really grasp the gravity of that distance, you have to realize it has completely punched through the heliosphere. That's the giant protective bubble of particles and magnetic fields generated by our sun. It shattered the termination shock, crossed the heliopause, and is now actively cruising through the pristine interstellar medium. I mean, it is literally existing in a region of space humanity has never physically touched before. Meanwhile, Voyager 2 is just slightly behind its twin, currently sitting at 137 astronomical units. That translates to about 20.5 billion kilometers away. But hey, even though it took that scenic planetary route we just talked about, do not let that fool you. It is plunging deeper into the cosmic ocean at an absolutely staggering speed. Voyager 2 is traveling at over 15 kilometers per second relative to the sun. Just the sheer kinetic energy carrying this machine through the total vacuum of space is wild to think about. Voyager 2 is traveling at over 15 kilometers per second relative to the sun. And this brilliantly illustrates the sheer, unimaginable scale we're dealing with. At distances like this, even light, literally the fastest phenomenon in the universe, takes a massive amount of time to travel. A one-way signal traveling at the speed of light takes about 23 hours just to reach us from Voyager 1. That means if NASA sends a command ping to the probe, it takes almost 2 full days to get a round-trip response. Seriously, imagine the nail-biting anxiety in the control room at the Jet Propulsion Lab. They beam up a critical life-saving software patch, and then they just have to sit there, sweating, for 46 hours to see if the spacecraft even survived the update. Section 3. Surviving Deep Space Challenges. Out there in the deep silence, way, way beyond the reach of the sun's warmth, traditional solar panels are totally useless. So how are these things still alive? The answer is plutonium-238. Both spacecraft are sustained entirely by radioisotope thermoelectric generators, or RTGs. As the radioactive plutonium naturally decays inside these units, it generates intense, vital heat. The RTGs then use solid-state thermocouples to directly convert that heat into usable electrical voltage. No moving parts whatsoever. And that converted energy is exactly what keeps these aging probes alive, ensuring their instruments stay warm enough to actually function in the freezing void of space. So the crucial point here is that this nuclear power is fundamentally finite. The radioactive material is slowly decaying, meaning it's generating less and less power with every single passing year. To delay the inevitable, NASA engineers are playing this incredibly delicate, high-stakes game of power management. They're executing a ruthless triage process, literally turning off vital heaters and sacrificing non-essential science instruments one by one, just to keep the core communication systems alive a little bit longer. But despite all these brilliant efforts, we are inevitably approaching what's known as the 2030 shutdown. Sometime around the year 2030, these nuclear batteries are going to fully deplete. And when that happens, both spacecraft will lose power entirely, leading to an eternal silence. Which brings us to our final topic, Section 4. Our lasting cultural artifact. This is where we pivot from the cold, hard engineering to something deeply, profoundly human. Fastened to the side of both ships is a physical gold-plated copper disc, the famous Golden Record. It is literally our planet's ultimate message in a bottle, cast out into the cosmic ocean. It holds a meticulously curated selection of Earth's sounds, greetings in 55 different languages, the sound of falling rain, and our music. But what's absolutely fascinating is how it holds visual data. Photos of human life, our anatomy, our homeworld. They are actually encoded into the physical grooves of the record as analog audio signals, meant to be decoded back into images. It even contains incredibly intimate artifacts. We're talking about the actual recorded brainwaves of writer Anne Drulian as she thought about falling in love, right alongside the simple, profound sound of a human kiss. So, class, as we wrap up today's explainer, I want to leave you with a final, profound thought to really chew on. Millions of years from now, long, long after the RTGs have gone cold and the transmitters have fallen perfectly silent, those golden records will still be intact. If some form of alien intelligence actually manages to intercept this silent artifact drifting through the interstellar void, what will they think of our planetary message? What will they understand about the people who sent it? It is a question that just echoes out into the deep silence, reflecting our lasting legacy in the cosmos, long after this class is dismissed. Thank you so much for joining me today, and remember, always keep looking up.